And welcome to video number 2 for section 3.3, and realize that the next several problems we actually have to use the graphing utility or the graphing calculator, and we are asked specifically in example number 11, which we will have several things to write down, but we need to use the graphing calculator in order to get the correct answer. We're going to graph the function over the indicated interval and approximate any local maximum and local minimum. And we're going to determine where it's increasing, where it's decreasing, and if necessary, we're going to round answers to 2 decimal places. Generally speaking, when we're using a graphing calculator, it will be necessary to round. And so let's pull this out, and the first thing we're going to do, we are asked to do over the interval -2 to 2. Well, I'm going to come here to the window button right here, and I'm going to change my x-min and my x-max. Now I don't want just -2 and 2. I'm going to go 1 on either side. So I'm going to do -3 and 3. And hopefully my y minimum and y maximum are fine at -10 and 10. But we'll see. If not, we may have to come back and change it. So then I'm going to go y equals, and I'm going to clear out whatever I have there. And then I'm ready to do x to the 5th power, and x to the 5th power will be x and then this caret to the 5th power. And realize your calculator is going to look slightly different. It will actually put a caret there. And then minus x squared. And I'm going to hit the x button and the x squared button. And so we get x to the 5th minus x squared, and hopefully that's between on the interval -2 to 2. And then I'm going to graph it and see what we end up with. Well, it looks like we've got something, and it looks like it may actually come up here and then just go slightly down below and then right back up. So I do need to be very careful there. I think I need to expand my y's just a little bit. So I'm going to change my window. Let's change my y min maybe to -2 and my y max to 2 and see what that gives me, and see if that helps anything on the graph. And let's see if it gives me any more detail. Oh, there, it's rather obvious. It seems to come up here, maybe touch at the origin, and then it comes down for a little while and then right back up. And so the first thing we want to do is we want to find out, are there any maximums or minimums? That's the first thing we want to do. So the maximum appears to be right here, or a local maximum, because it seems to turn around. Likewise, there seems to be a local minimum right around this area right here, because it hits a bottom and then it goes back up. Now, maximum and minimums do not occur at the -2 and the +2 because they go on forever. So minimum and maximum do not occur at that point. So how would we find this maximum right here? Well, that's a calculate problem. So it's going to be second, calculate. And you look at option number 4, maximum. So I'm going to hit number 4 to get the maximum. And just like any other guessing, it asks for a left bound, a right bound, and a guess. So I'm going to have to go to the left of my maximum anywhere. So there, I'm to the left. Then it's going to ask for the right bound, so I need to go here and hit the right arrow button a few times so that I go to the right of it. Hit enter, and then guess has to be anywhere in that area. And I'm just going to hit it somewhere close, and I see maximum is 0, 0. So that means I should be able to come here and say my max is at the point 0, 0. Now we're ready to find the minimum, because once we find the maximum and the minimum, the local maximum and the local minimum, and we have an idea of how the graph looks, then increasing and decreasing we no longer need the graph for, and we no longer need the graphing calculator. So now I want to calculate, so that will be second, calculate. I want the minimum, which is option number 3. And once again, it's going to ask, I need to go to the left of this spot right here. So I'm already there. I'm going to go a little bit closer. So there, I'm slightly to the left. Then I'm going to, it asks for a right bound, so I'm going to go slightly to the right of that minimum. And then it asks for a guess. And my guess is going to be about right there. And hit enter. And notice it says 0.74 negative 0.33. And so that will be my minimum, my local minimum. So let's come back here and let's say my minimum is the 0.74 negative 0.33, and it did tell me that I can round to 2 decimal places in the directions, so I can do that. Now I know that my graph looks like this, and I've got some very important points like 0, 0, and this point 0.74 negative 0.33, and I need to now say where is it increasing and where is it decreasing. So let's look at graph. I'm increasing here, increasing, increasing, until I get to that point right there, then I turn around and start decreasing. So that means I'm increasing anywhere from negative infinity all the way up until this point right here, the x value, which is 0. And then I start decreasing. I start decreasing between 0 and what x value right here? That's the 0.74. But then at this point I start increasing again. So I start increasing again at 0.74 and go on forever, all the way to infinity. And so I'm increasing from negative infinity to 0, and then 0.74 to infinity, and I'm decreasing between 0 and 0.74. Example 12, we're asked to use a graphing calculator, approximate local maximum, local minimum, and round to 2 decimal places if necessary. So this is just like number 11, except we don't need to do the increasing and the decreasing. So let's just give a space for the maximum and the minimum and realize there may be more than one of each one of these. There may be 2 maximum and 1 minimum or any combination. But what we need to do is we do need to go to our graphing calculator, and let's go to we are asked to do the interval -5 to 5, so the first thing I'm going to do is change my x-min to -6 and 6. I want to go one beyond each one, and let's start out y minimum as -10 and 10. Then go to the y equals and clear out what's there, because we no longer need that one. Instead, what we need is x cubed, so it's going to be x to the 3rd power minus 3x squared plus 1. And let's see what the graph gives us. See if we need to change anything. Okay, it goes up. There appears to be a maximum maybe at 0, 1, and a minimum maybe around 3, -3, somewhere around there. Just estimating. And so I know it appears I have 1 maximum, 1 minimum, and so now it's just up to me to find each one of those. So let's do second calculate. I want to do the maximum first, so that's option number 4. And I need to go to the left of my maximum, hit enter. I need to go to the right of my maximum and hit enter, and then guess can be anywhere along there. And it looks like -1.453 e -6y1. Well, this is 0. It's just a rounding problem. It's close to 0 without actually being 0 that you can probably get. So the maximum here would be 0, 1. And then to find the minimum, we just need to do another calculate, and this time we want minimum, which is option number 3, and we go to the left of the minimum, so anywhere there. Then it asks for a right bound, so we need to go to the right of that, and then guess anywhere. I'm just going to hit enter as my guess, and I see that the minimum is 2.000000003 -3, and realize yours may not be the same here. Once again, this is 2. a lot of times you have to have a common sense rounding on these problems in order to answer the question appropriately. Realize the minimum here would be 2, -3, which falls right in lines with my estimate. I thought it was going to be 2, -3, so that's pretty good. It fits right in line. So there are the answers for 11 and 12. Now when we look at 13, we have hot dog stand, and we've got a profit where P represents the profits and X is the number of hot dogs sold. And we ask, what is the most he can earn? Okay, well, there's no reason why we're looking for a maximum. So let's just plug it into the graphing calculator and see what we get. So I'm going to start my window. I know I'm not going to sell negative hot dogs, so I can actually start my minimum at 0, and I don't know, maybe 100 would be a good number of hot dogs to sell. I really don't know. But at the same time, I don't want all of my points to represent 1, so let's let every mark represent 10 hot dogs. Now likewise, if we're selling, hopefully we're not losing money, but we'll keep it at -10, and who knows, let's be real lofty, let's say we want $500 selling 100 hot dogs. Pretty expensive hot dogs, but that's okay. And once again, the scale, let's let the Y scale, instead of every mark representing 1, let's let every mark represent 100. As long as we know what our scale is, we can decipher it to a certain extent. Okay, so then I'm going to do Y equals. I'm going to clear out what I have, and I need the negative x squared plus 10x plus 31. Oh, well, that's okay. And then graph it and see what I get. Okay, well, I get this little thing, and I see a maximum here, but maybe my profit was just a little bit too optimistic, and so I'm going to come down here and change my Y max to maybe 100, because obviously I was under the number 1 mark, which would represent 100. So now I've changed my window a little bit. There it's a little bit more realistic, and I'm looking for that maximum right there. And the thing is, what is the most he can earn? We have to understand these are the number of hot dogs that he's selling. The Y values represents how much does he earn. So that's the most we want right there. So let's do a second calculate and do a maximum, option number 4. I need to be to the left of it, and realize it's quite a ways away. There it comes finally. Need to be to the left of it, so I'm slowly getting there. Okay, then I need to be to the right, and then I need to do a guess, and it gives me the answer 4.99999999656. So out of these, this is 5 and this is 56. What does it mean? It means we can sell 5 hot dogs and get $56 profit. This is very, very expensive hot dogs. 5 hot dogs we sell and still make $56 profit. I do apologize for the ludicrousness of this particular problem, but that's where we're at. Sorry.